Okay, so we're going to look at special products today. So we're still in polynomials. We're still extending our knowledge of polynomials. And we're going to go back to our old friend, the difference of two perfect squares. So if I gave you x minus 3 and x plus 3 and told you to multiply them together, we called this a special product because, bam, you should know the answer as x squared minus 9. You realize that the positive 3x and the negative 3x are going to cancel out. That makes this a special product. Well, we're going to look today and see if that special product can be extended to something else. So x cubed minus 27. If we gave this to you in 8th grade, I would have told you can't factor it. We can factor a difference of two perfect squares, but we can't factor a difference of two cubes, or can we? All right, x cubed minus 27. Well, let's look at this right here. This we knew to be squareds. A and A are 3 and 3, just one time it's negative, one time it's positive. And 3 is the square root of 9. And x is the square root of x squared. So let's play a game here. This is cubed, and 27 is a perfect cube. Since we looked at perfect square roots here, why don't we look at perfect cube roots here? All right, so the cube root of 27 is 3. And the cube root of x cubed is x. All right, so x minus 3, x plus 3? It can't happen because that's a perfect square. We'd need another x something or other. All right, so let's go back to this table multiplication and see what we get. I'm going to play around with first x and minus 3. We're going to look at a product. What times x minus 3 could possibly get me x cubed minus 27? Because after all, we're talking about special products, and products mean one factor multiplied by another. All right, so let's just start the reverse. Well, we know that this has to be x cubed. So this must have been x squared. X times x squared is x cubed, which gets me minus 3x squared. But we can't have any squares. We don't see any squares in this problem. So this has to be 3x squared. So they'll cancel out. And x times 3x gets me 3x squared. 3x times negative 3 is negative 9x. But we can't have any first degrees. We only have a cube and a number. So this has to be positive 9x. Can x, yep, if I put a 9 there, 9 times x is 9x. 9 times negative 3 is negative 27. Cancel, cancel. So I just found a product. I found that when I use the divisor x minus 3, if I multiplied it by x squared plus 3x plus 9, I got my perfect difference of cubes. Okay, well, that makes sense. But how about this a part where it's positive? Could I have x and then take the cube root of 27 and make it positive 3? Well, let's do some reverse work again. We knew this has to be x cubed, so this has to be x squared. That's going to be 3x squared. But in order for 3x squared to cancel out, that has to be negative 3x squared, which means this has to be negative 3x, which means this has to be negative 9x, which means this has to be positive 9x, so that has to be 9, and 9 times 3 is 27. Okay, we got to cancel, but we didn't quite get it done because we have x plus 3 times x squared minus 3x plus 9 would get me x cubed plus 27. Huh. Kind of interesting. Do you see a little quandary right here? This was a difference of two perfect squares. This is a difference of two perfect cubes. And well, I got it to factor. But I also got an addition of two perfect cubes to factor. We learned we can't factor x squared plus 9 back in 8th grade. But look here. We just realized we can factor a difference of two perfect cubes. We can factor an addition of two perfect cubes. Huh, pretty cool. Well, right here I have x cubed minus a cubed. You think you can figure out what that factors to? Well, let's start. The cube root of x cubed is x. The cube root of a cubed is a, and I'm going to look at the negative a part first. All right, I need x cubed, so this is x squared. Whoops, I need x cubed here. X times x squared gets me x cubed. That gets me negative ax squared. Okay, that has to cancel out because I don't have any x squareds in there, so that has to be positive ax squared. So that's ax times negative a is negative a squared x. And I have to have that cancel out, so this has to be positive a squared x. And I can get that by putting a squared there. A squared times x is a squared x. A squared times negative a is negative a cubed. Cancel out, cancel out. Beautiful. So I just learned over here that x minus a can get multiplied by x squared plus ax plus a squared, and that'll get me x cubed minus a cubed. Okay, well, let's look at it, the positive part. Okay, the cube root of x cubed would be x. The cube root of a cubed would be a, and we're going to look at the positive, see what happens. All right, I need to get an x cubed, so this is x squared. That gets me a x squared. All right, ax squared has to cancel out, so this has to be negative ax squared. So this has to be negative ax, negative a squared x. Hey, look at them just like the other table. That has to be positive a squared x. So that's a squared, and a squared times a is a cubed. Cancels out, cancels out. However, this time, x plus a, when I multiply it by x squared minus ax plus a squared, I didn't get my x cubed minus a cubed. I got x cubed plus a cubed. Okay, here's the beauty of math. Have you picked up the pattern yet? Let's try one more. X cubed plus 64. Well, cube root of x cubed is x. Cube root of 64 is 4. Wait, this was a positive, and you started me off with negative and negative. All right, so let's do the positive root first. Got to get an x cubed, so this has to be x squared. This is 4x squared. We have no squared, so this has to be negative 4x squared to cancel out. So this is going to be negative 4x. That's going to be negative 16x, so we'll need a positive 16x to cancel it out. So that's got to be 16, and that gets me 64. Okay, so when I have x plus 4, and I multiply it by x squared minus 4x plus 16, I did indeed get x cubed plus 64. Okay, let's see about that negative root, which I'm pretty sure you kind of figure out what's going to happen here. I need an x cubed, so this is an x squared. This is negative 4x squared. All right, so that has to cancel out with a positive 4x squared. So this has to be 4x. Gets me negative 16x. That has to cancel out with a positive 16x. So that's going to be 16. And 16 times negative 4 is negative 64. Cancel. Cancel. Huh. I got that x minus 4 times x squared plus 4x plus 16 gets me x cubed minus 64. Now I know there's a lot of writing on these pages here, but did you see the pattern? Let me clean it up for you a little bit. Okay, so when we were trying to figure out if x cubed minus 27 factors, it did. But along the way, we also found out that x cubed plus 27 factors. Likewise, with x cubed minus a cubed, we found out that x cubed plus a cubed factors. And likewise down here, x cubed plus 64 and x cubed minus 64. So I guess you figured out the point of the lesson, is that you can factor differences of perfect cubes or addition of perfect cubes. Okay, that's kind of obvious now. But do you realize how quickly you should be able to do it, just like a difference of two perfect squares? Well, let's look for the pattern. Let's see. In this one, let me get a good color here. Let me get pink. Oh, it's not really pink, it's red. When it's x minus 3, everybody in the second factor was positive. It went squared 1, none. And notice the coefficients. 9, 3x. Okay, let's look over here. When I had x cubed plus 27, and I started with x plus 3, I had almost the same exact thing, except it was minus 3x. All right, let's check here. X cubed minus a, we're going to start with the minus. Everybody's positive, just like up here. Notice this was a squared, and then the square root of a squared, which is a. Hey, did that work here? 9 square root of 9 is 3. Wicked! When I factored x cubed plus a cubed, starting with a positive, x plus a, I got the same thing as over here. It's just that it was negative in the middle. A squared, square root of a squared is a. And here's the positive over here. Start with the positive, so I should have a negative in the middle, and it should be almost the exact same factor as here, except x minus 4 means all of these are positive, but I basically have the same thing, just one sign is changed. So figuring out how to factor a difference of perfect cubes or an addition of perfect cubes is really pretty easy. So we know there isn't just a difference of two perfect squares. There's also a difference of two perfect cubes and an addition of two perfect cubes. So this is what we want you to learn. We want you to be able to factor a difference of two perfect squares quickly, a difference of two perfect cubes quickly, and an addition of two perfect cubes quickly. So you notice I skipped a page. This is what we'll start off with tomorrow to do a little review. Okay, see ya.